Hey guys, we're looking at how we prove triangles are congruent. These are our fill-in notes. So again, make sure you're following along in your Desmos, on your Desmos. All right, so if you're not seeing this slide, go ahead and refreshing Desmos. We're on for slide 6. So how do we prove that triangles are congruent? We're going to be seeing, right, in geometry, lots of figures. What we've learned so far in our class is it's very important to annotate our figures, right? So this first example is going to be, our first fill in the blank is if we have side, side, side. So what would that look like for our triangle? It means that all of their corresponding sides are going to be congruent. So I'm going to go ahead and fill those in. Remember, we use a tick mark to show that a side length is congruent. So if we were given this figure for a problem, we're making observations, we're like, oh, there's all these tick marks. Interesting. So what is that? Those tick marks telling us? It's telling us there is a side that's congruent, another side, and then another side. So we would say these triangles are congruent based on this postulate, side, side, side. No more information is needed. We're good. If all three sides are congruent, the entire triangle is congruent, right? The entire triangle is equal. That's what we're going to show in each of these different examples, right? We don't need to show every single angle and side matches up, right? That's going to be too crazy. We don't need to do that. All we're doing is going to be using one of these acronyms, and that's it. We can stop there. Our work is done. All right, next example is going to be, so next fill in the blank is side, angle, side. Again, make sure you're copying this on your Desmos. Side, angle, side. What is that going to look like? So we're going to have a side length that's congruent, the very next angle, and the very next side length. So again, it'll look something similar to our other triangle, our other figure. So again, it's a side, we're given an angle and a side, but it has to be the very next angle. On our notes earlier, we talked about included. So this middle letter, the A, it needs to be an included angle. Remember, included just means it's in the middle of, it's in between. So we have to have a side length, the very next angle, very next side, right? Notice that the angle is kind of sandwiched between these two corresponding two congruent sides, right? They're sandwiched in between. That's how we know. We see a figure like this. Okay, side, angle, side, and that's it. We would know that they are congruent. All right, third acronym that you're going to update on your notes is going to be angle, angle, side. And we're going to annotate the figure, showing just a general example of what this looks like. So we're going to have an angle, very next angle, and the very next side length that's going to be congruent. So for this triangle, angle, very next angle, very next side length. If they're out of order, if it's angle, angle, and a different side length, if it's not the very next immediately after very next side length, then it's not going to be angle, angle, side. Then it's not going to work. So again, if we see this kind of figure on our homework or during class, and we're showing these annotations, we're just labeling what information are they telling us? Are they giving us a side length that's congruent or an angle? And we're just going to label the figure. So I see right here there is an angle because there's one tick mark. Now we have a new angle that's going to be congruent to the other triangle. Another two arcs, excuse me, another angle. A tick mark over here means it's a side length that's congruent. And then we're done. Angle, angle, side. All right, give you guys a moment updating your Desmos. So we're doing side, 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 angle, side, angle, angle, side. Alrighty, our next one is called angle, side, angle. So we're going to have an angle that's congruent, very next side length, very next angle. So in this case, what is happening here is this is an included, now we've got an included side length, just like from our notes earlier. Included just means it's in between. So this side length is right in the middle, in between these two angles. All right, again, if we're given this figure, we're given these annotations, these tick marks and arcs, what do we do with this information? We're going to need to label our figure. So this is an angle because there's an arc here. We've got a tick mark. This is showing a side length that's congruent. And then 2 arcs, another angle for an angle, side, angle. All right, our last example is HL, which is standing. I'm going to write out what this stands for because all the other ones, S and A, S stands for side, A stands for angle. This one's kind of strange, so I'm going to go ahead and type this out. This is called hypotenuse leg. Hypotenuse leg. Hypotenuse leg. It's kind of a weird thing, hypotenuse leg. So just a reminder, where do we see a hypotenuse? This is only for right triangles. So I'm going to put that in here. Right, and then shorthand for triangles. Right triangles only. Hypotenuse leg, only if there is a right triangle. So given these 2 figures, we're going to go ahead and give some annotations because there wasn't any annotations. These were right angles. And let's say they said these were the corresponding side lengths that were congruent. So again, just a reminder, the hypotenuse, where that's at, hypotenuse is going to be this side length over here. Hypotenuse, let me copy that again. There we go, hypotenuse, there it is. Remember, the hypotenuse is directly across from the right angle, right? Like imagining we're standing in this corner, right? We're standing in this corner, we're looking out from the corner. That's the corresponding side length with those, with that angle. So hypotenuse is always directly across from the right angle. So this is our H, the hypotenuse. And what are they giving us? Hypotenuse leg for right triangles only. So if there is a hypotenuse, that side length is congruent, and also a leg, right? Another one of the 2 side lengths. That's all the information we need. We can say these triangles are congruent. But again, this is only when there is if it's a right triangle. If it's not a right triangle, it will not work. It will not work. So it's a special case, right triangles only for hypotenuse leg. Because no other triangle can have a hypotenuse. There has to be a right angle attached to it. All right, looking at the bottom here, we've got some little side notes, some information down here. And I'm just gonna draw out 2 tiny little triangles because I didn't give us enough room here. But just going to show, just as an example here. So if we have, let's say we're given a triangle and 2 angles are congruent, right? We've got angle, right? We only need 2 angles because the third angle has to be the same. Triangle sum property, right? Has to be the same. So if we're given only the same angles, these triangles are going to be similar, but they will not be congruent. So this is our goal here for this topic, is proving that they are congruent, that they're the same, they are equal. If we had a giant triangle with those same measurements and then a tiny baby one, you can kind of visualize that. They'll have the same angles, but their side lengths don't necessarily have to be the same, right? We can blow up the triangle or shrink it and the angles aren't changing, but the sides would be. So that's why it won't be, they're not going to be congruent. They're just similar triangles. And we cannot have this last fill in the blank is no donkeys allowed. No donkeys. No donkeys allowed. Absolutely no donkeys. Not only to keep it school appropriate, but mathematically it is not possible. They are not congruent. Not congruent. Not congruent. So if we are given a triangle, you might see this, right? Just to they'll try to trip you up, and you're like, oh my gosh, there's an angle, and there's a side, and there's a side, and you're trying to match it with one of these acronyms. You're like, oh, it doesn't work, right? Because it's always kind of like going in order. What are we given? We can't just jump around. Oh, there's random things. It has to be in order. So angle, side, side, or side, side, angle. Either direction does not work. All right, we're going to go ahead and add this to our notes in a moment. All right, make sure you got it down. Any questions, make sure you let me know. This is our acronyms for proving triangles are congruent. All right.